Yeah, so this is really just all intuitive. There's no algorithms to this. I may make a separate video on this because just this by within itself is not easily understood, but once you grasp it, it's really cool. You could actually solve the entire cube with just commutators and conjugates. Okay, so what you want to do is to get a commutator situation, you need to find a layer that has an oriented corner and a non-oriented corner. So here's our oriented corner on this layer, and we know that because the middle color is facing up on the corner, but it's not solved, and this one's just not solved oriented. Okay, so what we want to do here now is put these on the bottom, the stickers, the main stickers, and ask ourselves what goes in the oriented corner's edge. Well, what should be here is blue, white, and red. So red, white, and blue. So red, white, and blue is already really where we need it. It's right above it. Now, if you've ever done the beginner's method in solving a cube, you put it either above where it needs to go or the bottom, and you just do the toward, away kind of thing, whatever. But it's a little more intuitive than that, but it's just saying it's similar to where you're looking at what needs to go where. So what we want to do is basically get x, because x, y, x to the x inverse, y inverse equals solved. So basically x is going to be whatever move it takes for me to get this corner in its position solved. Okay, so let's figure out what that would be right now. We need to obviously get red here, and red's here. So it would be u prime, l prime, u, l. Okay, and now if we just did those moves in reverse, we're just going to get put right back where we were. We need to kind of kill that cycle and just do y. Y is just replacing the solved corner with an unsolved corner, and then do the inverse. So let's put it back, and it was what? It was u prime, l prime, u, l. So the inverse is just l prime, u inverse, and it was l, u. Okay, now we got to put y back where it was, so you have to do the inverse of that also. Okay, so as you can see, we got some solved corners out of that. We only have now 2, 3, 4 unsolved corners. So that might have solved 2, or it could have even been 3. Yes, you can still do this if you don't have the situation for a commutator. It just might only solve 1, which is okay. So let's find if we have another one here. Yes, we do. Here it is on the yellow layer. Is the oriented, non-oriented, and what we need to look for is what goes in the oriented one's position, which is going to be orange, blue, and yellow. So let's find that orange, blue, and yellow, which is of course got to be in the back bottom corner. So in this case, we're going to need our conjugate, which is going to be what we need to do to set up that situation we had before. So we're just going to put it on the bottom, and we know yellow needs to be on the bottom when we do move it. And so we're going to put it over the top where it needs to go. So this is another conjugator too. We have to undo those setup moves later. It's always good to write these down so you could do the moves backwards when you need to. So we need to get yellow on the bottom, which here it is here. So that way, to get this to the bottom, so basically this in its solved position here is going to be u, r, u prime, r prime. Okay, now it's there. We can't just do that backwards. We need to replace it, do our y move with this one, and then we're going to do those same moves back. So it was u, r, u prime, r prime, so it's going to be r, and so u, r, u prime, r prime. Now the u prime's inverse is u, so u, r, r's inverse is r prime, and then u is our first, so we need to negate or do the opposite as u prime.